Hello students, welcome back. At OrganiChemVerse, you learn concepts while you solve the questions, and today's topic is aromatization. So let's get started. First, analyze the given molecule. It is a spiro compound. What is a spiro compound? A bicyclic molecule where a carbon is common for both the rings. That means what? It is a quaternary carbon. And what else do we have in the molecule? There are two double bonds and then there is a ketone. And when it is treated with an acid, what should happen first? Remember, there are lone pair of electrons present on oxygen. So the oxygen will attack the proton because the lone pair of electrons will act as electron rich and proton is electron deficient. So this is the structure of the molecule we are going to get. Students, remember oxygen is divalent, but here in this case it is trivalent. That means what? It is not stable because of the positive charge. How can we stabilize it? By giving away the pi electrons present here. The moment the electrons goes to oxygen, right? Again, the oxygen will have two lone pair of electron. That means it is satisfying the octet configuration. Then what happens to this six-membered ring? So let's analyze that. The double bond here will remain as it is. Same with this also. Now, oxygen is divalent with two lone pairs of electron, but where should be the positive charge? Earlier, this carbon was tetravalent, now it becomes trivalent. Because of this trivalency, there is a positive charge on it. So we are generating a carbocation. So a neutral molecule, when it accepts a positively charged species, it will end up with a positive charge on it. So when oxygen, which is electronegative element, it is not able to withstand the trivalency, takes the pi electrons because the pi electrons are loosely held. Now we are getting a carbocation. How we can stabilize this carbocation? Either by this double bond or this double bond. It doesn't matter. You can move the electrons like this. And then what are we going to get? We are going to get a structure like this. Now, the positive charge is here. This is the carbocation we are going to get. Look at this carbocation. It is secondary carbocation. It is not so stable. And also, this ring wants to become aromatic because aromatic molecules are stable. So, in order to make this aromatic, we have to remove hydrogen from this carbon to form a double bond over here. But students, do you see any hydrogen over here? No, I already told you that this carbon is already quaternary carbon, no hydrogen attached to it. So because of this, what happens? Either this or this bond, okay, both of them are same, right? So it will break and it will give its electron to this carbon. What will be the structure of the product? So observe carefully. First we will write this part. You see the double bond is here, the double bond is here, and there is OH. Then since I am breaking this bond, I'll start writing the rest of the molecule here like this, okay? 1, right? 2, 3, 4. So we need to have 4 carbons. So 1, 2, 3, and then 4. So that is the one which is moving over here like this. Then what happens? This carbon, right? Earlier it was having 4 bonds. Now it is having only 3 bonds. Therefore, the positive charge will come over here. Is there a way to stabilize this carbocation? Yes, we have to remove hydrogen. So where do we have hydrogen? We have 2 hydrogens here and we have 1 hydrogen here. But which one are we going to remove? This one. Why so? Because by doing that, you are going to aromatize this ring. That is the reason, not these hydrogens. All right. So how can you write this structure? See here, I'm going to write it like this. Okay, this is where the OH is. And you see the double bond is over here, and there's a new bond formed over here. And we are going to get a 6-membered alicyclic chain like this. We have a phenol which is fused with the alicyclic chain. Both are 6 and 6-membered. So check where do we have it? We have here and here. So you can eliminate option C and D. But among these two, you can see the OH here is adjacent to this carbon. What about here? You can see that it is, if you take this as a ipso carbon, this will be meta position, right? And this is what we have as a final answer. Hence, the correct option is option B. So students, the driving force for the ring expansion, this can also be called as ring expansion because from 5-membered, you are forming a 6-membered ring. What is the driving force here? Aromatization, because aromatic molecules are stable. I hope I made this clear, and don't forget to solve the question given at the end of the video. Thank you for watching this video. Until next time.